the screen you can see the materials that we'll be using to construct our space station and their designated use. The main ship body will be launched from the Earth, containing inside its cargo port a landing module for extravehicular excursion. As the ship is delivered to the upper layers of the atmosphere, the solar panels will extend and start taking in energy into the hydrogen fuel cells, and the ship will take course to a rendezvous point with the asteroid.
As it crosses the orbit of the asteroid and reaches the rendezvous point, a secondary landing module is released to allow extravehicular excursion. A cylindrical shape will be adopted with a docking area to facilitate the landing pod for extravehicular excursion.
The payload with the mining products will be docked to the auxiliary docking port, with the top part is purposes as living area with its own dedicated docking port for the crew exchange. In case of emergency, the secondary engines that are situated on the top of the craft are activated, detaching the top part off, acting as a launch escape system for the crew.
We have designed a relaxing and functional living quarter, with a bedroom, toilet, shower room and storage room to ensure the crew's needs are met. All of the furniture will be fixed to the floor and walls with hook and loop fasteners. The beds have adjustable belts, so the crew will not float around and injure themselves by colliding with furniture. This ensures the crew receives highest quality sleep. Furthermore, we care for the crew's physical and mental health, so it is carefully monitored by a smart mirror. Also, we try our best to provide an Earth-like environment, where temperature and lighting are regulated to prevent circadian desynchronization. For any unforeseen emergencies, backup meals are stored, emergency suits are positioned at the exits, and evacuation is made efficient through corridors more than 1 meter wide.
Waste produced is recycled. Ammonia produced in Zimmermann process is used in the growth of algae. Laser-induced spectroscopy is used as it's non-destructive with high efficiency. A closed system involving Sabatier process, electrolysis and syngas reaction is used for atmospheric control. Humidity is regulated by hygroscopic nanofibrous membrane-based moisture pump, which requires a low amount of energy since it's based on diffusion, while heat produced is stored by RXTES process for heating. 450 kg of dehydrated food is carried to spacecraft and rehydrated by a rehydrator. 4 ion thrusters are used to propel the spacecraft due to high efficiency and speed. A thrust is created by accelerating ions by electric and magnetic fields. Weight is reduced by substituting neutralizer with DC self-bias voltage and using krypton instead of xenon as fuel. Microalgae are harvested for generating electricity by producing biodiesel due to its oil-rich nature. Excess glycerol is recycled by microbial fuel cells. Silver nanoparticles are added to electrodes with Shimonella to maximize efficiency through capturing more electrons. Power generated is stored and excess is stored as backup for emergencies.
For extravehicular excursion, we designed the rover as shown. There is a mechanism internally which produces a torque, allowing it to hop into free space. With the spinning of the arm which introduces a direction, the rover is able to jump over a great distance to adjust its position marginally after the hop. The secondary maneuver mechanism, omnidirectional anchoring, is activated. At the end of the robotic leg, there are tiny claw-like structures which grip tiny irregularities on the surface. Mechanical snubber is also used to reduce the impact on the electronics. The other equipment are LiDAR sensors and HAZ cams controlled by the terrain relative navigation system to avoid big obstacles. The whole rover is powered by the multi-mission radioisotope thermoelectric generator using the heat of plutonium's radioactive decay. Extra electricity can be stored in 2 hydrogen fuel cells. Gamma-ray spectroscopy, involving the precise measurement of gamma-ray photon energies emitted by different nuclei, can establish nuclear energy level structures and allows for the identification of trace radioactive elements through their gamma-ray emissions. After observing the asteroid and planning out where to mine, the robots will be deployed to a designated location. The robots will then inject an expensive, non-explosive demolition agent made with mostly calcium oxide and water. After the agents expand, the asteroid will crack under pressure and break into smaller pieces. The robot will then deliver the rocks into the box. Temporary docking of the spacecraft will be achieved by attaching electromagnetic pads to the asteroid. To despin the asteroid, the method is as outlined.